Hello everyone, very good afternoon all of you. How are you all? Good afternoon, welcome back to Unify Study. Yes, all are ready? All are ready? Yes, to do the mind mapping? All are ready to do the mind mapping for computer networking? Yes, we will start here. Let's start without wasting time. Yes, how many of you are here? Please like, share, subscribe to the channel everyone, and please share it to all of you because Unify Study is now 20k family. I am so happy and thank you so much for your love and support. Really, we are so happy. Small steps, now we are 20k and I am very much thankful to all of you for your love, support and everything. Yes, so let's start. Here today your class will be, as you know, every day I am giving you all the mind mapping. We are doing mind mapping, we are doing question, and ultimately from this class you are getting 100% confirm question. 100%. I am telling you 100% means 100%. Confirm questions will come from here. Yes, confirm question. Video to stuck. It is the regular that is going on. Video stuck. Chalo. Without video only I will do. It is also a what I say. I can't say anything. I don't want to say anything. So chalo, yes, let's start without wasting time. So here how we have to relate in computer network. What are that? Yes, thank you. Thank you, for your best wishes. Thank you. So here IP addressing, what are that means how you have to relate the mind mapping, how to do the mind mapping for computer networking. Actually in computer networking throughout the syllabus you have to learn these layers. Ultimately there are Wi-Fi model and TCP IP model. These are the two models. And under Wi-Fi model there are these 7 layers, and ultimately throughout the syllabus you have to learn on these layers only. What are the functionalities of this layer, how these layers are working, and what are the protocols we are using. That is in detail. You have to dig more all this layer, and that is only in your computer network. Other than that nothing is there. So that's why whenever you are learning this subject, always I am telling that story. Think about that. Nowadays the popular things are WhatsApp, Facebook. You are messaging. The messaging is going on. So here are you and here is your friend. You are doing chatting between each other. You are sending message to your friend. When you are sending message to your friend, then how the communication is going on. You are in Kolkata, your friend is in Mumbai. Now how the communication will be going on, how you are chatting with your friend, how it is possible. That is only in the networking. This is the subject where you have to learn what is going on when I am sending the message, how the communication is going on, how the work is going on. Okay, so whenever application layer means that is your app, through which app you are connected with your friend. In your mobile you are using different app for your communication purpose, like WhatsApp, Facebook and other app. And for your study purpose, definitely use the Unify Study app. Okay, you are using lots of app, I know that, but must install the Unify Study app for your study purpose. go to Google Play Store and install it, and definitely all of you please rate, review and comment, and must install this app in your mobile, because this app will help you to do your practice. There are lots of free mock tests available for you, which mock test you can attempt and you can get the benefit. That will be good for you, and I will provide you more mock tests day by day. That's why it will be definitely help you. So whatever app we are using, that is actually the application layer, means where I am working, what is visible to you, that is the application layer. After that, coming to the presentation layer, what is going on in the presentation layer? Presentation layer means how you are presenting the data. You want to send a mail, so whenever you are sending the mail, then you are designing the mail template you are using, you are sending image, you are sending videos or something. So how to present it, that is the task of the presentation layer, where the encoding, decoding, encryption, decryption, everything is going on. Okay. Next thing is coming to the session layer. What is the task of the session layer? Whenever you want to send something, then you have to connect with the server. Whatever app you are using, you have to connect with the server. That server is your, means with the server you have to create your session. How you are creating your session? Through the login. You log into the system. After login to the system, you have, for you there it is created a session. It will create the session for you, and after that you can connect with the server. So session is, means it is giving you that connection. You are connecting with the network. Right now, that is your session. After that, coming to the transport layer. Transport layer, what is going on? Transport layer, actually the ultimate transportation going on. This is the heart of the Wi-Fi layer, where the transportation going on. You are sending the data, that is the transportation. And network layer. Network layer is the very important layer. And throughout the networking subject, you have to learn a lot in networking layer. In network layer, there are so many things to learn, and from where questions are coming more. This is the one layer and this is another layer. Ultimately, this two layer is your area from where more questions are coming. That is the network layer and data link layer. Here the logical addressing and physical addressing going on. Network layer is doing the logical addressing with the IP address, where through the IP address you can identify the network. Each and every network have the separate identification number, that is the IP address. Through the IP address the connection will be established, and through the IP address it can identify your sender, your receiver, everything. Here the routing is also going on. Here the gateway protocol is also there. Everything is working in the network layer. Data link layer is working with the physical addressing, that is the MAC. Physical addressing is going on in the data link layer. It is working with the frame. And after that, ultimately physical layer means what you can see in front of yourself, that is your wear and physical devices. That is ultimately physical layer, and physical layer is working with bit. And after that, now these all the transmission is done from your side. After that, ultimately the same layer, the data have to pass from your friend side. Physical layer, data link layer, network layer, session layer, because you send the data, but if your friend is not connected with internet, if your friend is not connected with the server, is it possible that it will be delivered to your friend? You are doing WhatsApp with your friend, but actually your friend deleted the WhatsApp app from his mobile. Now this will go to your friend. Is it possible? Your friend will be able to reach? Your friend will be able to get it? No. Because if you are connected with the server, so you will be send it to the server. Now server will send it to your friend, but your friend should be also connected, and the same layers are there for your friend also. Physical layer, after that it is physical addressing, IP addressing, transport layer. Your friend is also created the session. In the presentation layer, whatever you send, that encrypted data, it will be decrypted, then ultimately it will come to your friend in application layer, that is his WhatsApp. So that in this way your communication will be going on between you and your friend, and that is the topic to learn throughout the networking here. Is that clear? Is that clear to everyone? And those who are watching, please like, share and subscribe. Everyone. A hall ticket for to release today. Hall ticket will release before exam. You will get your hall ticket. Don't do panic with the hall ticket. They are doing delay. So what is the meaning of doing panic? At the last day you will get your hall ticket. They are not releasing nowadays early. That is their habit. So don't do panic with the hall ticket. It will waste your time. They will release one day before your exam. Okay, so don't do panic. Where is the meaning? Buy again and again hall ticket release. You will get it. Don't worry. You will get it. Okay, because they are not giving. What you will do? What we can do? What I can do? So here these are the software layer. That's why these are the software layer. What is connected with your software? Application layer, presentation layer and session layer. Because through the software layer only you are using it. Transport layer means it's come out from your software, from your device. Network layer, data link layer and the physical layer, these are the hardware layer. These are not related to your software. These are the hardware layer, and this layer, that is the transport layer, is the heart of the WSI model. Okay, so here is the hop to hop and end to end. What is hop to hop? Whenever this is your mobile, this is your friend's mobile, now this is going on. So one hop to another hop means actually one router to another router, this transmission is going on. In between there are so many routers when you are sending the data. End to end means actually it came to your network. With that it have the port number also, through which port number your application is connected. Because after coming to your network, after coming to your system, it's required the port number also, because without port number there are different apps. Out of that, which app you are sending through WhatsApp means your friend will get also in the WhatsApp. He will not get in any other app, right? So that's why the port number is also required. So a hop occurs when packet is passed from a network segment to the next hop. So data packet through the router travel between the source to destination. The hop count refers the number of intermediate devices through the data, that is called the hop. Okay, so hop to hop use the MAC address in data link layer deals with this. Hop to hop data link layer is deal with this. Host to host, whenever you are coming, that is use the IP address. Network layer is doing handling with that. Next one is the end to end, that is the IP address plus port number. So the transport layer is dealing with the end to end. And MAC address means media access control address, that is the unique identifier assigned to each and every interface controller. That is the MAC address. Very important questions are coming from here. Definitely remember it. And every time whenever you are sending the data from one layer to another layer, the header it is adding the header. So always each and every layer will add some header and some extra information with that. And ultimately whenever it is coming, then again the decryption means it will one by one it will check the header and from there it will send to the next. In that way ultimately you will get the data. Right. So these are the some important functionalities on application layer. Application layer service that used with the user application, just now I told. Presentation layer, encryption, decryption, very important operation. Remember that. Encryption, decryption, encoding, decoding, everything is going on here. These are the examples: JPEG, GIF, HTTPS, these are the format. Session layer, establish or end the connection between two hosts. These are the examples. Transport layer, there are two types of protocol. One is UDP protocol, another is TCP protocol. TCP is the connection oriented protocol, UDP is the connection less protocol, where it is working in the transport layer. Network layer is working with IP address, routers, switch is working in that layer. Data link layer is working with MAC address, where it is called the frame, and switch is also working here. Physical layer, finally the hub, NIC, these are your physical layer. Okay. This is very important in Wi-Fi layer. Whenever you are coming, this is the name, because whenever you are shifting from one layer to another layer, then the name is changing. So but just like a river, when the river is flowing from the Kashmir to Kanyakumari, the same river name is different way, different area they are calling in different name, different area. Same way, when the data is flowing from one to another layer, then the name are different. Actually data is same, but the name are different. So application layer, presentation layer, session layer is calling that with data. Transport layer is calling with segment. Network layer called with packet. Data link layer with frame, and the physical layer with bit. Very important. Remember, these questions are 100% topic. These are the layer questions are coming, so must remember it. Okay. Okay, these are the some protocols, list of protocols. Sometimes questions are coming with the protocol also. In the application layer, which protocol is working? In presentation layer, which protocols are working? In network layer, which protocols are working? In data link layer, in physical layer, transport, all the layers, protocols are important, and you have to do the mind mapping of the protocols also. Presentation layer. Okay. Is that clear till now? Whatever I told, is it clear to everyone? Is it clear to everyone till now, whatever I told? Yes or no? So this is your final revision. Whenever the video will be stuck, I will again off it. Okay. It's a game going on with me and you. Yes, so here you can see, whenever you are comparing with the TCP IP layer, whenever it is comparing with the Wi-Fi layer and the TCP IP layer, then you can see in the Wi-Fi layer there are 7. That is application, presentation, session, transport, network, data link, physical. One by one, each and every layer. Numbering is also very important. Questions are coming with the sequence, with the numbering also. And now you can see these 3 layer together in TCP called as application layer, because TCP have only 4 layer. Okay. Transport layer name is itself transport. Network layer name is network layer. Data link layer and physical layer together name is network interface. So in WSI 4 layer can be divided into this combiningly it is under 4 layer. 7 layer is divided under the 4 layer. So as you saw, these are the main applications going on. So whenever the question is on TCP, then just relate with the WSI layer. Okay, what was the work of the WSI layer? You can relate with that and you can then answer. And what are the some devices? These are the devices also you can remember. And now here the devices, what are the main work of this device? That is also sometimes questions are coming. Repeater working in physical layer and it is working with 1-to-1 port. Okay, what is the main task? That is the regenerate of the signal or attenuation, means when signal strength is getting low, then the repeater is regenerating the signal to give the strength to the signal. Hub is working in physical layer also. It is working as a broadcasting addressing. It is dealing with bit and basically it is the multi-port repeater. Do the mind mapping. One by one it's increasing. Okay. Next one is listen to my audio only. Next one is that the bridge, whenever the bridge is there, then the data link layer MAC address. It is working with the MAC address and the frame deals with frame. Send data to the destination using the MAC address. Here switch. Switch is actually the buffer is there, data buffer, store data into the buffer and send after error checking. That is the extra advantage in the switch. Next part is the router. Router is working in the network layer and it is working with IP address and deals with packet. So router is working with one network to another network through the IP address. That is the main thing. Gateway is also working the IP address, but entrance to the different network model, means gateway is just like the border of one country to another country. Totally network model is different. One country to another country, whenever it is moving, then total model is different. That is the gateway here. Okay, clear? Is that clear? Is that clear? Yes. Next one is that these are the terminologies I told already, the hop to hop, host to host and end to end. Now do the questions. Now do the questions so that your revision will be done. Yes, answers are coming. Option 4 is the correct answer. Definitely. Data link layer is working with frame. Network layer is working with routing. Transport layer is connection control. That is the TCP and UDP. Presentation layer is working with encryption. And that is the answer. Now next one. Do the next one. Do this next one and it's hiding. Wait. Yes, what will be the answer for this one? Physical layer, data link layer, network layer, presentation layer. What will be the answer for this one? Yes, this one is also option 4. Physical layer is working with what? Data, the bit. Physical layer is working with bit, that is break connection, define voltage, data rate, convert the bit, that is the physical layer. Data link layer is working with the frame. Right, so frame means here it is, you can see even also the flow control, error detection, that is also the part of the data link layer. In the data link layer, what is going on? Synchronization, error detection, correction, all this into the frame. Next one is the network layer. Network layer is working with routing of the signal, divided outgoing message in the packet. So here presentation layer, it's work with the translating layer, where translation, encryption, decryption, encoding, decoding, all the translation is going on in the presentation layer. Now tell me what will be the answer for this one. All these layers are working of the layers are very important. Do your mind mapping, take a notes of these keywords of different layer. 100% sure you will get the question from this area. 100% sure. What will be the answer for this one? Yes, here answers are coming. Again you can see the session layer, very important role of the session layer is token management, synchronization, token management. This is a very important role of your session layer. Other than that, here you can see the end to end. This is the keyword of the transport layer, end to end connection. Other than that, the data link layer is piggybacking and network layer is producing the billing information, because here through the network layer these are the works going on. Now you can see the protocols. What are the protocols are working in which layer? SLIP, BGP, Border Gateway Protocol, UDP, User Datagram Protocol, Simple Network Management Protocol. What are the protocol used in which layer? I told you that you have to remember the protocols also. They are asking protocols also in different layer. So it is your question on protocols. Yes, here the answer will be 2. Border gateway is working in the network layer, so 2 will be with 4. So here it is actually A, B, C, D. Okay, so B will be with 4. You can see here B with 4. This is not the answer. These are any one of these are not the answer. Serial line IP, SLIP. SLIP is working in the data link layer. After that, UDP, TCP and UDP is the transport layer. Simple network management protocol, that is in application layer. So these are the different protocol in different layer. Now you can see another question again from the layers. So your all the layers mind mapping will be done with these all questions, and must prepare your notes if you did not prepare till now. Your notes will help you. Tell me what will be the answer for this one. Yes, option 3 is the correct answer. Here the token management, again you can see the token management is the key word. So in the session layer the token management is going on. So C will be with 1. Transport layer, what is the thing? The raw bit, here you can see transmission of raw bit where it is in the physical layer. Is it connected with the transmitting raw bit over the communication channel? So it is under the physical layer. The syntax and the semantic, that is the part of presentation layer. Syntax, semantic, presentation layer. And end-to-end protocol, this is the keyword, end-to-end layer, that is transport layer. These are the keywords. Must remember these keywords. These keywords will help you to identify the answer. Okay. So this is so already you know. Now tell me what will be the answer for this one. What will be the answer for this one? Basi layer. Yes. So in the session layer main work are dialog control, token management and synchronization. These are the 3 main work of the session layer. Dialog control, token management and synchronization. Write it down, note it down, otherwise you will forget. You have to do the mind mapping through the question only. You can write down in your notebook the keyword, whatever keyword I am marking. Those keyword in different layer. Only write the keyword. Only write the keyword. That will help you. Now tell me what will be the answer for this one. Which of the following device takes data sent from one network device and frameworks to the destination based on the MAC address? Based on the MAC address. Yes, here your answer will be switch. Switch is sending it. Switch is doing that work. Very good everyone. Now tell me what will be the answer for this one. What will be the answer for this one? Yes, here high chance you will do the mistake. It is a high chance that you are doing the mistake. Here the device that you are thinking about the packet, and that's why you are giving the network layer, and that is the wrong answer. Read question very carefully. Which layer divide each message into packet at each source and reassemble them? It is division going on and the reassemble is going on. Divide the packet into actually segment, and the segment is actually the transport layer. Although they use the name packet, but the dividing packet network layer is sending the total packet. But divide and reassemble means that is the segmentation, and that is done into the transport layer. This is the new way of question. Directly they will not give you the keyword, because with the keyword you are trying to identify the question. So that's why you have to read the question very carefully. If you are not reading question carefully, then your answer is coming Wrong. Got it? Got it. Everyone is doing the same mistake. It is not the network, it is the transport layer. Now tell me, after this one I think we did. This question is done already. So here is the difference. So now we will do some difference between different protocol. What are the difference between different protocol? That is we will do now. It is the main difference TCP and UDP. TCP means transmission control protocol. UDP means user datagram protocol. So TCP is the connection oriented protocol. Connection means it will make the connection before sending, and it will do the handshaking from one side and another side. The handshaking will be done, then only it will send the data. But UDP is the connectionless. No connection is required. It is just working as broadcasting or multicasting type. When the message is only sending as a broadcast message, user will receive it or not, that is they are not bothered about that. I will broadcast my message, those who are receiving or not, they are not bothered about that. Okay, so TCP is reliable for guarantees that delivery and send to the router, and here there is no guarantee, cannot guarantee, because it is not making connection. So how it can give the guarantee? TCP is error checking mechanism because the flow control and acknowledgement of the data is here. But here UDP basic error checking mechanism using the checksum. This is the basic mechanism. Basic mechanism is there using the checksum. Priyobroto, yesterday also I told you that every day what is the meaning to ask? Why you are not checking at 11:15, 11:30 the class is going on. Every day you are asking same question. Transport protocol. Here transmission protocol, that is TCP, user datagram protocol UDP. Here are more difference. Here are the thing, that is you can see TCP comparatively slower than UDP and UDP more efficient, right? Transmission lost packet in the TCP, but UDP not. It can lost also. Here the header size, this is header is always 20 byte, that is fixed. We will work on the header also. Question is very important. And remaining it can be till 60. But here it is very less, that is 8 byte only. That's why it is heavy weight and this is low weight. It does not support the broadcasting and it is supporting the broadcasting. What are the different protocols working under TCP? That is HTTP, HTTPS, FTP, SMTP. And here under UDP, DNS, DHCP, TFTP, RIP, SNIP, VIAP. These are all the protocols under UDP. Sometimes questions are coming in little bit indirect way also. They can ask you question, and be ready for indirect question. They can give you the example of TCP. After that they can ask you in the application layer which protocol will work here. Then you have to be very careful. Under TCP what was the protocol, under UDP what was the protocol. Okay, so remember that. Now you can see the question and tell me what will be the answer for this question. What will be the answer for this question? Those who are watching, please like, share, subscribe. This 3 button is very important. Please click these all buttons. What will be the answer? Everyone. Yes, answers are coming. Option 1 is the correct answer because TCP handle both connection and the congestion and the flow control. That is correct. UDP handle congestion but not flow control. That is wrong. UDP is not handling anything. Congestion also not. Flow control also not. Now you can see the difference between ARP and RARP. That is the next protocol. Very important protocol. ARP means Address Resolution Protocol. RARP, Reverse Address Resolution Protocol. What is the meaning? Because there are mainly, I told you, the logical addressing and physical addressing. MAC to IP, IP to MAC, that connection, that translation is required. Who will do that translation? That is this protocol. Okay. The node use the ARP broadcast and LAN using the broadcast MAC address. RARP broadcast IP address it is using. So map IP address to the MAC. So it is sending IP to MAC. And here it will get the MAC address and it will send the IP address. MAC to IP, opposite one. Very, very important. Repeated questions are coming from this area. Okay, so host router physical addressing and here the local host maintain the ARP table. Here RARP server maintain the RARP. Because when I am getting IP to MAC then local address is okay. But here it is MAC to IP. That's why it's required the server. Okay, ARP reply this update with the ARP table. RARP reply with the configuration IP address. You can see the question in front of you. Tell me what will be the answer for this one. What will be the answer? Yes, answers are coming. That is definitely ARP. Which of the protocol used to acquire the MAC address of the host whose IP address is known? IP address is known means IP to MAC conversion is going on. That is ARP. So it will answer will be ARP here. Now the difference between Telnet and FTP, that is also very, very important difference. What is the main difference between Telnet and FTP? Telnet stands for Telecommunication Network. FTP is the File Transfer Network. Ultimately the one host to another host, the file transfer is going on. That is the FTP. That is the target of FTP. Telnet is the chat operation. Telnet used for the chat operation. Port number of the Telnet is 23 and port number is the FTP is 20 and 21. Telnet used for one connection. FTP established two connections. One for controlling the command and another for the data transfer. The remote login is necessary in Telnet and here remote login is not necessary in FTP because through the user ID or password you will connect with the server and you can fetch the data or you can upload the data also. That is the difference between Telnet and FTP. Here are the some more difference, that not private security on the general security. It's provide high security here, and here the remote I already told, the connection oriented protocol. It is also the connection oriented protocol, but difference is this is working with file and this is working with chat. That is the main difference. Okay, next one is the DNS. Port number 21 for data transfer for the protocol. The protocol, each and every protocol have different. Each and every protocol have, yes, the 20 and 21 both, because it is establishing two connection. It is establishing two connection, that's why the 2 port number. Okay. Okay. Yes. Now you can see the DNS lookup. How the DNS lookup is working. What is the DNS? DNS means domain name server. You are working with that key unifystudy.com. You will search the name unifystudy.com, right? So how the browser will be able to understand where is Unify Study? How the network will understand where is Unify Study? Because network know only the IP address. Network don't know anything. That's why the IP domain name to IP conversion is required. How their conversion will be going on? We are generally storing previously, nowadays so we are storing everything in mobile, but previously when you are in the age of 10 years or 8 years, when we was the kid, at that time we are writing the phone number in a phone book, right? That is the index. So whenever you are searching the phone number for a relative, then you are going to search with the name of the relative and you are getting the phone number. This is the same thing in the DNS also going on. DNS is storing all the name, all that name, and this is the unique name always. Unifystudy.com, there will be throughout the world there is only one Unifystudy.com. There will be no other Unify Study, and it is not possible that there will be multiple Unifystudy.com, because the domain is allocated to the Unify Study itself. So in this name there is a IP address also. That IP address is pointed because the server is pointed. So this is the conversion required. When you are searching with the name here, the unifystudy.com, then it will go to the DNS resolver. First it is going to DNS resolver. Then it is coming to the root server. Root server means .com, .org, .in. These are. After that it is coming from the root server to, it is coming to the TDL server, means exactly for the .in there will be a different TDL. .com there will be the different TDL. It will come to that TDL server. Now it will search exactly the name Unify Study where it is. Now after that it will get it. In the 6th then 7th it will get it. After getting it, again it will send here. Then ultimately it will get the IP address. Okay, this is the IP address. Then it will connect with the server, and from the server it will get the data. This is the way how your DNS lookup is going on. Okay. Clear? DNS is clear. Very important. These are the protocols are very important. Next important thing is POP and IMAP. What is the difference between POP and IMAP? How this is working? Both are working as a mail, for the mailing purpose. POP is the post office protocol. POP, another name is post office protocol. IMAP is what? That is all the internet messenger access protocol. What is the main difference? POP is working locally into the local server. POP is working locally in your local machine, but IMAP is actually you are working in the server. Sometimes you are installing any we are using some internet messenger. Okay, Gmail app, we are installing it. So whenever internet is not there, then also you can read your mail, because it is stored in your local server, local machine. But here if you are opening directly gmail.com, then you can check your mail in that server only. If your internet connection is not there, then you cannot see that, right? That is the difference. So POP mail can only access from the single device at a time, because the application will be installed in a single device, and it can be accessed everywhere because you are directly connected with the server. Read the mail has downloaded into the local system, and mail content is partially you can see before downloading, because whenever any new mail came, you can send some line that is from where the mail came, the first part of the body, you can see that before clicking also, before downloading also. Is it or not? So user cannot organize the mail into the mailbox for the mail server. Here it can be organized, because ultimately user is working in the server. This is the main difference between POP and IMAP. Is that clear to everyone? Yes. Next one is the SMTP, Simple Mail Transfer Protocol. What is Simple Mail Transfer Protocol? This is we are using for sending the mail, and in application layer. SMTP is working in the application layer. It have actually two types, that is end-to-end method and store and forward method. End-to-end model use the communication between the different organization, and here there are user agent and local MTA. How they are working? User terminal, sender, then user agent, then send the mail into the queue, then in between the client, that is MTA, message transfer agent is there. Now here TCP connection will be satisfied, you will establish the connection. After that it's coming to the another MTA, then it is going to the user mailbox, that is the receiver mailbox. Through the user agent, finally it's coming to the user terminal, that is the receiver terminal. This is the way how the SMTP working. What is the workflow of the SMTP? Very important, the workflow. Sometimes they are giving options and they are asking that what is the correct sequence, 1 2 3 4, like that you have to tell the correct sequence. Okay, tell me what is the answer for this one. What will be the answer for this one? Answer. What will be the answer? Sometimes the chats are not coming. Yes, answer is MIME, M-I-M-E. In electronic mail, the following protocol allow the transfer of multimedia. Multimedia means MIME, that is multi-purpose internet mail extension in the internet standard, that is MIME. So you can remember that the full form. Even also this is important for your ICT also. They can ask you the ICT question also. This is required. Okay. Now the next thing is the multiplexing. Different types of multiplexing are there. First one is FDM, next one is TDM, next one is WDM. When the signal, these are different signal. Okay, so three types of multiplexing are there. FDM means frequency division multiplexing, TDM means time division multiplexing, of WDM means that is wave division multiplexing. Nothing else. The questions are same, because just by mistake I give you the answer, but this type of questions are coming. What is the main difference? Whenever you are sending it to the sender to the receiver, one data, right? You are sending it to the sender to the receiver. Now bandwidth will be divided. How the bandwidth will be divided? That is according to frequency you can divide, or according to time slot you can divide, or according to the wavelength also you can divide, so that different sender can get the chance for different send. Okay, tell me what will be the answer for this one. I'm coming in 1 minute. Yes, so here the answer will be option 4. Frequency division multiplexing technique can be handled by digital circuit. That is wrong, because here you can see the time. Here the frequency division multiplexing technique is applied when the bandwidth of the link is greater than the bandwidth of the signal, because you are dividing the bandwidth between the each and every signal. So definitely capacity should be more, then only you can divide, otherwise you cannot divide it. And wave division multiplexing technique used in optical fiber for combining two signals. That is correct. So option C and D will be correct here. Now you can see this is very popular question. CDMA, GSM, UMTS and Wi-Fi all are related to your mobile network. Everything is related to your mobile. So tell me what will be the answer for this one. What will be the answer for this one? After that again I will try to switch on my video. I have to go for servicing of this. Yes, here the answer is CDMA, GSM. GSM very important. GSM is related to your TDMA, time division multiplexing. Remember that. CDMA is related to your access mechanism of multiple transmission over single channel. UMTS is provided the mobile network faster transfer rate. Wi-Fi allows the connection throughout without wireless channel. These are the different one. Okay. Acha, I will come to the flow control now. Video, I am really, morning the video is working, afternoon the video is not working. It is a what state? I am not able to understand. In which state I am? See, now this will not work. My laptop is not able to take that much. Okay, no problem, please carry on. I am feeling lot bad that why this is not working. I am feeling bad for that, but there is no other option. So stop and wait, go back and selective repeat. There are different flow control mechanism. Different flow control mechanism. Okay, so here are the different flow control mechanism you can see. So here how it is working. What are the main difference? Yes, my daughter is singing. She came from the school. She have the annual day. Now practice is going on. And now she came and she started singing. From the annual day practice she came and now she started. So stop and wait means what is going on in stop and wait. When sender to receiver, this is under the data link layer. Flow control means where the flow control is going on. It is in data link layer. Okay, in the data link layer, this is a very important part of the data link layer. So here, when sender to receiver, you are sending the data, then stop and wait means only one frame transmit at a time. Only one frame at a time, only one frame will be sent. Okay, that is the stop and wait protocol. First sender will send the packet to the receiver. After that, if receiver will get it, then it will get the acknowledgement. After getting acknowledgement, only sender will send the packet. Otherwise, it will not send the packet. That is called the stop and wait protocol. Okay. So here you can see the sender window is 1, receiver window is also 1. And what is the efficiency? What is the efficiency of stop and wait? 1 by 2a, where a equals to TP by TT. Very important. Remember that. Already 10 marks question came from here. Very important. A equals to TP by TT. An independent acknowledgement here. Retransmission. How many retransmission? Because when one packet lost, then only one packet it will send. That's why retransmission will be 1. Sequence number will be 1 plus 1, because for the sender when I am 0, then after that next one is 1. Sequence number will be required 1 plus 1. Always the sequence number depending on sender plus receiver. How much data sender is sending, whatever receiver is receiving, it is depending on that. That's why the sequence number is 1 plus 1 here. Go back in. How it is working? Sender is sending multiple packet at a time to save the time, because whenever I send one packet, to get the acknowledgement I have to wait. That much time it will not wait. Without waiting, in that time gap, that is the 2 TP gap time is there. Within that gap time it will send more packets, so that there will be no wastage of time. That is called go back in. But receiver is receiving one packet only at a time. Sender is sending multiple packet, but receiver is receiving only one packet at a time. Okay, so here that is the reason. Here you can see the multiple frame transmit. Sender window will be 2 to the power k minus 1. How it is coming? If the k number of bit is allocated total sequence number, then total possibility is 2 to the power k. Out of that, receiver will be only 1. That's why sender can take only 2 to the power k minus 1. Very important. It is 2 to the power k minus 1. And receiver window will be only 1 here. Receiver window is only 1 here. Okay. Then the multiple frames, selective repeat is sending here the, what is the efficiency? What is the efficiency here? Efficiency is n by 1 plus 2a. N by 1 plus 2a. N equals to 2 to the power k minus 1. Very, very important. Acknowledgement, cumulative acknowledgement. What is the meaning? At a time whenever you are sending multiple data, then after sending the multiple data, at a time, after getting 2 to 3 data together, it is sending the acknowledgement. That's why it is called cumulative acknowledgement. Retransmission will be always n number of retransmission. That is a problem. Here the problem is n number of retransmission here. Because why? Because if sender send one packet, after that in between it lost, but next two packet receive, but receiver is going to reject that packet, because receiver is always accepting with sequence, and that's why n number of data again you have to resend, and sequence number will be here n plus 1. Selective repeat, how it is working? Selective repeat is dividing the sender and receiver into half and half. Means if my capacity is 8, then sender window size is also 4, receiver window size is also 4. So at a time I am sending 4 packet, receiver is also receiving 4 packet. If by chance any one is not received, then it will send a negative acknowledgement, and it will retransmit only that specific one. Unnecessarily multiple retransmission is not there. That's why here the sender window size is 2 to the power k minus 1. Very, very important difference. Very carefully understand it and remember it. I will ask you just now question so that you can do the mind mapping. This is 2 to the power k minus 1, and this is 2 to the power k minus 1, because total possibility is 2 to the power k, divide by 2. For sender also half, receiver also half. That is the main difference. And sequence number will be n plus 1, n plus n. Is that clear? I will check it. Is it clear or not? I am going to check it. And please video help me. Again and again I am trying, but it's not working. I will ask you one question just now. I am really feeling very bad. Okay, do the question. I will ask you some questions now. So here is the stop and wait, how this is working. You can see sender, receiver. After the timeout, then sequence you will send. These are the problems, efficiency in stop and wait. And go back in. This is your go back in sliding window protocol. I am going to ask you some questions. Do those questions. This is the sequence number. This is already we discussed. Tell me, what will be the answer for this one? What will be the answer for this one? Tell me. Yes, that is selective repeat ARQ. That is selective repeat ARQ. Yes. Next one, tell me what will be the answer. Next one, quickly tell me. And go back in ARQ. If 5 is the number of bit of sequence number, then the maximum size of the send window size, what it will be? That will be definitely 31, because 2 to the power 5 minus 1. 2 to the power 5 minus 1, that is 31. Very good. Now tell me what will be the answer for this one. What will be the answer for this one? Yes, here you are doing mistake. See that. Here all of you, most of you are doing mistake. Here 5 is the sequence number maximum size of the receiver window. Receiver window is always 1 in go back in. In go back in, receiver window is always 1. Always 1. Don't do that mistake. Receiver window is always 1. Ritu, you are doing mistake. That's why I am asking, so that you can do the mind mapping. Now tell me what will be the answer for this one. What will be the answer for this one? Yes, here your answer will be 16, because selective repeat half. Selective repeat. This one, next one, what will be the answer? For the next one, what will be the answer? Yes, this one will be also 16. Sender, receiver, both will be half. Total was 32, that is 2 to the power 5 is 32. Sender also 16, receiver also 16. That is the answer, 16 and 16. Yes, correct. Now tell me what will be the answer for this one. Now can you tell me what will be the answer for this one? In GB3, if every fifth packet being transmitted is lost, if we have given send the 10 packet, then how many retransmission are required here? What will be the answer? Do it and tell me what will be the answer. answers are coming here. I can see that you are giving answer. Answer will be option C. How to do that? How to do that? Here every fifth packet lost. Easy way is that, see that here it is GV3, means go back 3. Sender window size is 3 here. So ultimately sequence number will be 0, 1, 2. That is will be the sequence number 0, 1, 2. Again you are sending like 0, 1, 2. But to do the calculation in easy way, I will suggest you take the packet number as 1 to 10. So that your calculation will be easy. So that your calculation will be easy. How to do that? 1, 2, 3, 4, 5. This is the fifth packet. So this fifth packet lost. Actually what is going on in the first frame 1, 2, 3 was there. In the second frame 4, 5 and 6 will come. In the third frame 5, 6 and 7 will come. Actually the frame is moving one by one like this way. This is the way the frame is moving one by one. Okay. So when you send the fifth number of packet, then actually in this frame these 3 are present. These 3 are present in this frame. Okay. So 5 is lost. 6 will be also lost. 7 will be, means 6 will be discarded by the receiver. 7 will be also discarded by the receiver. Now you have to send 5, 6, 7 again. That is the retransmission. Because the problem is that when sender send the fifth packet, that was lost. After that sender seeks the 6th one and 7th one. Although it is sent, but receiver is going to reject it. And that's why sender have to send 5, 6 and 7 again. That is the problem here. So this was your fifth position. From here you have to count again. First, second, third, fourth, fifth. This is again your fifth position. This is again lost. That's why in this frame more 2 packet will be there. That is 7, 8, 9. 7 lost means 8 will be discarded. 9 will be also discarded. Now you have to send the 7, 8, 9 again. This is the fifth one, means first, second, third, fourth, fifth. This is again the fifth one. And you have to resend again. In that frame there was 9 and 10, because after 10 nothing else is there. So both are discarded, means you have to resend again the 9 and 10. 9 and 10 have to resend again. So now you have to count how many total transmissions are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Total 18 transmissions are here. This is the easiest way to solve this type of question. Got it? Is that clear how to solve? Is that clear how to solve this question? And your flow control, all the concept, means stop and wait, go back in and selective repeat. All these concepts are clear. What is the main difference between them? Are you able to relate it? Are you able to relate it? Yes. No, there is no formula. Everything will be no formula, and don't think about the formula of success. There is only one formula of success, that is your concept. Everything conceptually you have to understand. If you are thinking about everything about formula, there is no formula of success. Only you have to work on concept. Okay? Yes. Now come to the remaining questions, that is your comprehension type question was there. So now we will do the comprehension type question. Can you solve this question? This is the comprehension type question of UGC NET 2022. They ask 5 into 2 10 marks question on this topic. And today's class I will cover all those 10 marks question in networking. Repeated they are asking comprehension type question. So these all the comprehension type question we will solve here one by one. Do it. We need to do frame segment next to next. Frame segment next to next means at a time 3 you are sending. At a time you can send 3 frame at a time. So whenever anyone is lost, then remaining 2 will be also discarded. That is the concept. Okay, do this one. What will be the answer? A 3000 kilometer long trunk operates at 1.536 Mbps and used to transmit 64 byte frame and use sliding window protocol. The propagation speed is 6 microsecond per kilometer. So what will be the transmission and propagation delay? That is the question here. So the distance is given 3000 kilometer. Bandwidth is 1.536 Mbps. Packet is 64 byte. So propagation speed will be 6 microsecond per kilometer. That is the propagation speed here, right? So here this is the propagation speed. So the transmission delay will be what? Transmission delay formula is packet size by bandwidth. Packet size is 64 byte. Bandwidth is 1.536. So 64 multiplied into 8 byte. Definitely always remember byte convert in bit. Very important. And another thing is very important. File size. You are writing like KB, MB, GB. That will be converted into byte like 2 to the power 10, 2 to the power 20, 2 to the power 30. But the speed, bandwidth, this we are writing like kbps, mbps, gbps. This is kilobit per second. Small letter b means that is bit. And capital letter B means that is byte. Always the byte you need to convert in bit. 1 byte equals to 8 bit. At the time of doing networking calculation, very careful about that. And this kbps you have to convert in bit per second, 10 to the power 3, 10 to the power 6, 10 to the power 9, like this way. Okay, KB 2 to the power 10, MB 2 to the power 20, GB 2 to the power 30. This is in 2 to the power. But KBPS, MBPS, GBPS, it is in 10 to the power. At the time of calculation, if you are not taking care of this unit conversion, then your networking numerical will be wrong. And from networking 100% confirm you will get numerical, because networking subject is that 70% numerical, 30% theory. Totally 70% thing is depending on numerical, and there is no way of leaving this. From networking you are getting more than 15 questions, that is 30 marks also can come. More than 30 marks also can be there in networking. That is the current trend. So there is no way of leaving this subject, and you have to be very careful at the time of conversion. That's why you can see the 64 byte we have to convert in bit, 64 multiply into 8. And these Mbps's we have to convert in bit per second by multiplying 10 to the power 6. After that, the calculation is also very important, and here you can apply the trick. What is the trick you can apply? You can see here that actually this 333.33 is not required here. By doing only 6 microsecond propagation, you are getting here that 1 kilometer propagation delay is 6 microsecond. So that's why 3000 kilometer propagation delay will be 3000 multiplied into 6, that is 18,000 microsecond. So from here you can do the answer. This is already 18,000 microsecond. This is not my answer, this is not my answer, this is not my answer. Definitely it will be my answer. Still, if you have to calculate, then also you can do the answer without calculator. How I can do the answer? This is so definitely not my answer. Check it exactly what is my value. 64 multiplied into 8, and here it is 1.536. Right. So try to go for little bit assumption, means near about value. If I am doing 64 multiply 8, my answer is coming 512, right? 64 into 8. 512 divided by 333.33. It is here, and after that 333.33 not, sorry. Here it is divided by 1.536. So see that from here you can predict little bit value, that if I am 512, if I am dividing by 1, then my answer is coming 512. If 512, if I am dividing by 2, if I am thinking about it is near about 600, so near about 300 my answer will come. But this is 512, so my answer will be little bit more than that, because it is not 2, it is 1.536. So now from here you can get it कि this is not my answer, this will be also not my answer. I can get this will be my answer, because without calculator, whenever you have to answer, then without calculator you have to go for this way. In this way you can do the answer. Okay. Yes. Chalo. Ishwari, go around in all the YouTube channel and ask everyone that what about admit card, what about admit card. Forgot about your study. I am telling everyone that stop doing this admit card, admit card. What you will do with the admit card? Admit card will be required when you will go for exam hall then. Before that, what you will do for admit card? They are not releasing admit card early. You will also go for exam hall. Others will also go for exam hall. It is a request to all of the students, don't panic with the admit card. NTA is like that only, they are doing delay. And you have to be habituated with that. If you are doing panic and if you are wasting time with admit card, you will not do study. It will be not good for you. Long back ago I uploaded a video and I told everyone don't panic with this. Before your exam you will get your admit card. Why you people are not thinking it? Forgot about that. You will get it. You will get it. Prepare yourself. Prepare yourself. to prepare yourself. That is definitely will come before exam. Admit card will be required to go to your exam hall. You will get definitely before your exam. There is no meaning of wastage of time like that. You will go everywhere, you will message everyone, ma'am admit card, sir admit card. We are not providing, NTA is providing that. Maybe it's my something whatever I am telling, sometimes it listening very bitter way, but it is the bitter truth only. There is no meaning of wastage time with this type of things. There is no meaning. Focus on your study, you will get it. Okay, chalo do this one. And whenever admit card will be released, definitely I will update. Definitely I will update. Tell me what will be the answer? What will be the answer for this? Yes, here your answer will be 109. How to do it? Here it is asking you sender window size, get the maximum efficiency. What will be the sender window size to get the maximum efficiency? That is the question. So just now you calculate the transmission delay also, all this data. So here the propagation also we calculate. So A is TP by TT. That is the formula for A. So your TP is 1800 and TT is 333.33, right? So it will be 54. After that your window size, optimal window size formula is 1 plus 2A. That is the optimal window size to get the 100% efficiency. So 1 plus 2 multiply into 54. Your answer will be 109. This is the formula to get the optimal window size. So answer is 109. Tell me what will be the answer for this one. What will be the answer for this one? Yes, here it will be the answer will be 7 bit, because just now we did the optimal window size is 109. Question is asking you the minimum number of bit required in the sequence number of the packet. What is the minimum number of bit? So optimal window size I got 109. So number of bit will be log 109. Now log 109, 2 to the power 10 is 1024. 2 to the power 7 is 128, right? 2 to the power 6 is 64. So 6 bit will be not possible. I have to go for 7 bit because it is 109 will be satisfied with that. So that's why I have to go for the 7 bit. 7 bit will be enough. 6 with the 6 bit I cannot do. So my answer will be 7 bit. Now what will be the answer for this one? If only 6 bits are reserved for the sequence number field, then the efficiency of the system. What will be the efficiency of the system? Yes, here my efficiency of the system, because original requirement was 2 to the power 7, but I have 2 to the power 6, right? Because 6 bit means my window size will be 2 to the power 6, that is 64. 64 by 109 means my answer is coming 1.587, 0.587. Exact value, near about value you can calculate. With the near about value also you can do the answer, or you can go for exact value also. How to calculate this exact value? 100% means 109. So 10% means 10.9. 1% means 1.09. Like this way think it, you will get the answer very quickly. You have 64. So 64 means how I can get the answer? My 10%. 10 multiply 6, that is 60. So definitely it is not 6. 10.9 multiply 5 if I am doing. So 10.9 multiply 5 if I am doing, then I am getting here this one, that is 59.5. I am getting here 59.5. Yes, so it will be more than 50%, and after that 0.8 you can calculate. So this is the way, if you are doing, then also you can get the very accurate answer. Okay, that is the way also you can convert, and in backtracking also you can do. You can do the backtracking also. 0.587 multiply into 1%. That is also you can do. So because you don't have calculator, without calculator you have to do, means you have to practice this also, ki without calculator how I can do it. I don't have calculator. In UGC NET you will not get any calculator, but without calculator you have to do this. Tell me what will be the answer for this one. What will be this one? Yes, here your answer will be efficiency, the throughput is efficiency multiply into bandwidth. Just now you calculate the efficiency, that is 0.587. So 0.587 multiply into bandwidth, that is 0.536. You will get the answer 0.901. So your answer will be 0.901. Must practice the elimination method and getting closer value, because exactly 0.587 multiply into 1.536, if you are going to do, then you are gone. Try to think as a closer value. If I am doing a closer value, how? Because 0.500 multiply into 2 means it is coming 1.000. Right, so it will be 1.000, but my value is 587 and here it is 1.5. So my value will be very close to 1. So out of the option you can choose this one. This is the value very close to 1. This method you have to apply in exam hall, otherwise it will be very difficult for you to get the correct solution and you will waste lot of time for doing this calculation. So it is my suggestion, go for this method, that getting the round off, do the round off and get the closer value and do the answer. That is the best way. Okay. So now here these are the till now flow control done. We did all the flow control. Now we have to go for the error control, and in the error control very important thing is Hamming code. Before starting Hamming code, I will check once again the camera is working or not. I have to cry again. Wait 1 minute, let me try once again, then I am coming. জিমন্যাস্টিকে যাচ্ছিস? Okay, I will go without camera only. Okay, let's go for the, I am taking, these are the problems. If you are focusing on problem, then you cannot continue. Any YouTuber is not there, I think, that those who are taking live class like this way. Camera problem, mic problem, but I can't stop. We can't stop. We have to do, right? We can't stop. So let's go for error control. I will, some student was there, those who was asking about Hamming code. Are you there? Someone was asking me about Hamming code for a long time. Are you there? Who was asking about Hamming code for a long time? Ma'am, explain Hamming code, please. Ma'am, explain Hamming code. From a long time this request was coming. Are you there? Someone was asking me about Hamming. Yes. So how the Hamming code is working, I am telling you. Hamming code. So you can see here, yes, Hamming code is working for error correction. It is working on error correction. Okay. How the error correction is going on? Error correction is going on. It will check the sender data and it will check the receiver data. Between the sender code and the receiver code, it is doing some XOR operation. After doing the XOR operation, it can get the Hamming distance. Hamming distance. So what is that Hamming distance? Hamming distance means, just if I am taking the example like that, one is KAROLIN, that is the sender data. Receiver receive like that, KATHRIN. Now see that. What are the differences here? You can see here is a difference, here is a difference, here is the difference. So how many differences are there? 3 differences are there. That is called the Hamming distance. Means the difference between the sender bit and the receiver bit. That is called the Hamming difference. Now how it will be able to understand, because computer know only 1 0. So if you are taking the number as 11101, that is the sender data. Receiver receives 00, then 1, then 001. This is the data. Then I have to do the XOR operation. See that 1 is 0, 0 is 0, 1. Here there is the difference. That's why it will get 1. 1, this is 0. Here is 1, 0. That is 1. Here it is 0. Here it is 0. So wherever I am getting 1 means there are the changes. Here 1 means here are the changes. So it will get that, okay, 2 digit I am getting 1 means there are Hamming distance 2. So 2 difference are there. That is the simple thing, that how I can check the difference. How I can check the difference. This is the way you can check the difference. Okay. Normal thing is that. This is called the Hamming distance. Difference between the two code. That is called the Hamming distance. Okay. Now the next thing is that minimum Hamming distance. Minimum Hamming distance for error detection. Minimum Hamming distance for error detection is always D plus 1. That is, the D is the number of, what is the distance you will calculate. And minimum Hamming distance for error correction. Minimum Hamming distance for error correction. That is 2D plus 1. This is for error detection. Okay, this is the first thing. After that, here this is not that much simple, because here whenever the Hamming code is working, how it will able to detect it, for that there is a little bit complicated method. What is that complicated method? It is adding some redundant bit at the time of sending. With the data, it will add some redundant bit with the data, so that with the redundant bit it can get the error. With the redundant bit it can find the error. So for that, how many redundant bit to be added? For that there is a formula, that is 2 to the power r. 2 to the power r equals to m plus r plus 1. Using this formula, you can get it ki how many redundant bit will be required. How it is? If my data bit is 2, think like that. If my data bit, that is M is my data bit, that is 4, then you have to calculate ki what will be R, means how many redundant bit I have to allocate. How I can do? Do the trial. That if I am putting R equals to 1, what will be happen? 2 to the power 1 greater or equals to 4 plus 1 plus 1. Is it satisfying? No. If I put R equals to 2, then what will be happen? 2 to the power 2 greater or equals to 4 plus 2 plus 1. Is it satisfied? No. If I am putting R equals to 3, that is 2 to the power 3 greater or equals to 4 plus 3 plus 1. Is that satisfied now? Yes, because this is 8 greater or equals to 8. This is satisfied now. So as this is satisfied now, so I can get it R is 3. Got it? This is the first step. Now what I will do with this, ma'am? Why this is required? Because here the requirement is here that whenever there are 4-bit data, then I will add 3 redundant bit. How it is? You can see here it is working like this way. Always the redundant bit will be in the position of 2 to the power n. So I will fix the position here, means my data is 4, redundant bit is 3, so total 7 bit I have to arrange. So 7 bit whenever I am arranging 1, 2, 3, 4, 5, 6, 7. This is 1, 2, 3, 4, 5, 6, 7. These are the 7 position. Out of that, redundant bit will be in the 2 to the power position, means this is 2 to the power 0, this is 2 to the power 2, these are the position, and this is 2 to the power 1 position. So that's why my redundant bit, that is redundant 1 will be here, redundant 2 will be here, and redundant 3 will be here. Remaining part will be my data part. That is, this one is my data, this is my data, this is my data, this is my data. This is the way you have to put it. Okay. After that, what I will do with this, ma'am? What is the requirement of doing this? The requirement of doing this is, whenever there will be a message like that, maybe the question is asking you that you are sending a message. Like, maybe if I am taking an example that ki original message, that is given that original message is 11001110. Okay, and due to some error, receiver received that. The receiver received the message like 11011110. This is the message receiver receive. Okay, and here it is using the even parity. It will be given, it is even parity or odd parity, using that it will give. Now where are the problem? You have to find out that in which bit, in which position the problems are there. That is, you have to find out. So how you can find out the problem? To find out the problem, you have to place this bit first. 1, 2, 3, 4, 5, 6. So it is your 1, 2, 3, 4, 5, 6, 7. This is my 7 bit. Now put the data, whatever you receive, the receiver data, because you don't know that original data, you receive the receiver data and you are checking now. So 1 1 0 1 1 1 0. Now error detection. First of all you have to detect it. Is there any error or not? How to detect the error? It is my, sorry, I give the wrong way. This will be 1 2 3 4 5 6 7. In opposite direction I have to put 1 2 3 4 5 6 7. Now my redundant bit position is fixed. That is, this is my R0 position, this is my R1 position, and this is my R2 position. Okay. So R0 position is checking the bit of 1357. R1 position will check the bit of 2367. And R3 position will check the bit of 4567. Why it is? No need to memorize. There is a meaning of this one also. What is the meaning? I am telling you. Here if you are using a 3-bit number like R0, R1, R2. Okay. 0 0 0, 0 0 1, 0 1 0, 0 0 1. 0 1 1 1 0 0 1 0 1 1 0 1, then 1 1 0 and 1 1 1. Now you can see for R0 where are the 1? 0 1 2 3 4 5 6 7. Okay. For R0 where are the 1? You can see that. That is 1 3 5 7. That's why R0 is checking the bit of 1 3 5 7. For R1 where are the 1 2 3 and 6 7. That's why R1 is taking that 2 3 and 6 7. R2 where are the 1? You can see that 4 5 6 7. That's why for R2 4 5 6 7. If you understand the concept, then if there are instead of 4 data, if there are 6 data, 7 data, you have to take the redundant data more like 4-bit data, 5-bit data. Then also by doing the truth table you can get the calculation that for R3, R4 what will be my combination. Is that clear? Till now is it clear? Those who are watching, till now is it clear to everyone? Those who was asking, there was so many requests was coming for Hamming code. That's why I am explaining. I hope you are watching and you are getting it. Please reply me. So that is the reason R0, R1, R2 is this fixed bit it will check. Now the event parity. See that how to check the event parity. Here for R0 you will take 1, 3, 5 and 7. These are the bits you are going to check. Right? 1, 3, 5, 7. So tell me, is this correct? And this is so here first of all original bit, and after before that also how to put the number 5, find it, then after that fill the back. Confused how to fill, how to fill I am telling you. How to fill, that is also I am telling you. So how to fill it, that is I am telling you. Same way you have to fill. If your data is like that, ki my data is given 1101. Okay, so I will put the value 1 1 0 and 1 in that position, because this is the R3 and R2 position. Okay, this is 7 6 5 4 3 2 1. These are the positions here. Now this is your R0 position, this is R0, R1 and R2. Okay, you can write it R1, R2, R3 or R0, R1, R2, anything. If you are starting with R1, R2, R3, then you can R1, R2, R3, or you can do this one also. Okay, whatever your choice, you can do it. That is no bindings. So I am using here R1, R2 and R3. But the problem is that I have to fill the data with 1, 3, 5 and 7. Now check it. Here is 1, here is 1, here is 1. Is it even or odd? Is it even or odd? Is it even or odd? Is this even or odd number? Tell me. 1, 3, 5, 7. I have to check R1 as 1, 3, 5, 7. R2 as 2, 3, 6, 7. Odd number. So if you are working with the even parity or odd parity, now you have to check this one for 2, 3, 5, 7. It is according to even parity also possible, according to odd parity also possible. Whatever your choice. Whatever your choice. If you are maintaining even parity, then you have to make it even. If you are maintaining odd parity, then you have to make it odd. Okay, how the even parity and odd parity is working? For even parity, the number of ones are odd, then parity value set to 1. Okay, otherwise 0. Whenever you are working with even parity, if the number of ones are odd, then set to 1. If you are working with odd parity, then what will be that? If the number of ones are even, then parity value set to 1. That is the thing. Okay. If it is odd, then I have to make it even. That's why it is set to 1. Here it is, if it is even, then parity bit will be 1. That is the thing. So if here I am working with the even parity, then what will be happen here? As this is the odd number, 1, 1, 1. This is a odd number. I have to make it even. 1, 3, 5, 7. Next one, for R0, it was 1 R1. For R1 it was 1, 3, 5, 7. For R2 it will be 2, 3, 6, 7. So check the 2, 3, 6, 7 position. 2, 3, 6 and 7. This position. Check it. 2, 3, 6, 7 position. What is happening? In the 3 here it is 1, 6 here it is 1, 7 also here it is 1. So it is again odd. Again I have to make it even. So that's why here also I have to put 1. Right? Last data. Last one is that R3. R3 is 4, 5, 6, 7. So for 4, 5, 6, 7 I have to check that in the 4, 5, 6, 7. This is the even number. 6 and 7 is the even number. 5 is 0. In the 4 I have to fill it. So now it will be 0. Now this is 0. Got it? Got it? Yes. Clear? Is that clear now? How it is working? How this is working? Is it clear to everyone? How to put the value? How to put the value? Just check the position of this one, R1, R2, R3. Here don't be confused with the number. Here I am making R1, this is R2, this is R3. Here also I am making, this was R1, R2, R3. Here also this is R1, this is R2, this is R3. So that there will be no confusion. Okay. Yes. So now can I ask you question? Can I ask you question now? Where you are getting confused? See that here this is the question. And you are getting confused with this one. Same question ma'am, but it is not matching. Is that your confusion? Ma'am, it is the same question just now whatever you did. But the answer is not matching ma'am. That is your confusion, right? That is your confusion. That this is also 1101 ma'am, but it is not matching here. How to do that? Because here is a problem. If you are taking in this order, that is in this order 1 2 3 4 5 6 7, if you put here 1 1 and this is your redundant bit 1, this is your redundant bit 2 and this is your redundant bit 3, and after that here 0 1, just now how what we did here, that is this way we did 1 1 0 1, that was like coming here, but it will not work here. Why? Because you can see every option, if it is coming with 1 1 0 1, any option is not starting with like this. First 2 will be 1, here also first 2 will be 1, here 1 0, here it is 1. Any option is not matching. At least first 3 will be 1 1 0, right? At least the first 3 will be 1 1 0 according to that. But any of the option is 1 1 0, not here. So why it is not matching? Because they did it in opposite direction. How the opposite direction? In this way. They are creating 1 2 3 4 5 6 7. They are creating confusion in this way. 1 2 3 4 5 6 7. In this way you are writing. Then what it will be? See that this is your R1 bit, this is your R2 bit and this is your R3 bit. Okay. Now you see, now if you are writing the number 1 0 1 1 in this way, then you will see your option will match 1 0 1 1, because here you can see the last 3 bit is matching with this one. Last 3 bit is matching with this one. After that, this if you are filling it, then also it will be correct. Try to fill it. First R1 if you are filling, that will be 1 3 5 and 7, right? So you can see this is the odd number, this is odd number, so R1 will be filled with 1. So that's why fill R1 as 1 1. Then R2 2 3 6 7. R2 is 2 3 6 and 7. R1 was 1 3 5 7. R2 will be 2 3 6 7. R3 will be 4 5 6 7. 4 5 6 7. So now in R2 what to put here? This is 1. Then 1 2 4 6 7, right? 2 3 6 7. It is 1 and this is 0, this is 1. So that's why what will be the value of R2? This will be 0 because it is the even number. As this is the even number, you have to put here 0. That's why put here 0. Then finally R3. 4, 5, 6, 7. 4, 5, 6 and 7. That is your R3. So here it is 1, here it is 1. That is a even number. Again this is the even number. So that's why this value will be what? 0. This value will be also 0. Right? That's why here put the 0. Now you can see the correct answer is coming. This is the answer. The answer is coming here. That is 1 0 1 0 1 0. The answer is coming. This is the answer. So how to understand in which direction I should took? I should took in this direction or this direction? How to understand that? By checking the option, check it. If you are taking in this direction, then first 3 bit should match. If any of the option first 3 bit is not matching, then try to aim for the opposite direction, the last 3 bit. Last 3 bit is matching or not. If the last 3 bit is matching, then take it from the opposite direction. Okay. So what was coming here? Your R1 bit was coming 1, your R2 bit was coming 0, and R3 bit was also coming 0 ultimately. And here also we took the same example, right? Here whatever example was given to you, 1 1 0 1, I took here that example only, 1 1 0 1. And here also you saw that R1 bit was coming 1 and R2 bit was coming 1. How? Here I did any mistake? 2 3 6 7. No, right? I did not any mistake. Opposite direction when it is taking, then I think it is coming different. Two, 3, 1 1 0 1. This is the 3 6 7. Then it was coming even. But here when we took this one, then for R2 it was coming 0. 3 6 7. Opposite way it was coming. That's why it is coming opposite. Got it? If you are taking in opposite direction, then your answer will come different. It is in reverse order. That's why it is coming different. So I hope all of your confusion is clear. So many students was getting confused about this question, and I hope all of your confusion is clear why this is the answer. In this way examiner is creating the confusion. Okay, clear to everyone how it is working? How it is working, it is clear. And I was taking this example that this is my original code. How I will understand ki where is the problem, in which bit problem it is. If you check the R0 is correct or not, check here. For R0, 1 3 5 7. So 1 3 5 and 7. If you are checking, it is working with the even parity, right? So here it is 1 and here it is 1, this is 0. It is working fine, it is even parity only. 2 if you are taking, 2 3 6 7 for the 2. So this is 2, this is 3 6 and 7. Two, 3 6 7. Is it even parity? Is it even parity? Yes, because this is even or odd? 2 3 6 7. Is it even parity? It is working even parity, no problem. Now if you are coming to R3, you can see that next one, that is 4 5 6 7. In the 4 5 6 7, this is 4 5, 6 and 7. Is it even? You can see it is not even, it is odd. Odd number of 1 are there. So this is not matching. Now out of this combination, now check it. All this combination. 1 was correct. 2 was also correct. 3 is also correct. From here I can get that 5 is also correct. 6 is also correct. 7 is also correct. Then out of that, which one is missing? Which one is missing? Here you are getting combination 4, 5, 6, 7. Out of them you got 5 correct, 6 correct, 7 correct. Because this 2 is correct means 5, 6, 7 is correct. Right? So which one is not correct? 4 is not correct. So you can identify the number that this 4 is not correct. Here is the problem. So you can rectify the problem that okay, here is the problem means actually my answer will be 1, 1, 0 and this 1 will be actually 0, then 1, 1, then finally 0. Are you getting the original number? You are getting the original number by identifying the problem. The problem was 7, 6, 5, 4, 3, 2, 1. Problem was in the 4th bit. Here is the problem and you are able to identify the problem using the combination. Using this combination you are able to identify the problem and you are able to find out that yes, 4th position there is the problem. So you can rectify the error. This is the way Hamming code can detect and correct the error also. How it is detecting and correcting. Got it? How this is able to detect and correct? Clear? Is that clear to everyone? How the Hamming code is working? I hope completely clear. Error detection, error correction, how to add the redundant bit. Chalo. Now go for the next. Now we can move for the next. Yes. अरे यार कुछ reply तो दे दो. After facing lots of technical problem and everything, still I am coming live because of you. And whatever requests are coming to me, always I am trying to take care of those requests. I will go for others, then don't ask me because I am going to erase this page. I am going to erase this page, then you will tell me, ma'am, this is not able to clear, this is not clear, then I cannot clear your doubt. Clear? Okay, good. Very good. So that's why your answer you got here in the Hamming code. Now tell me what will be the answer for this one. Now tell me what will be the answer for this one. Answer not here. Okay, sorry. This is the not question. Here I will tell you that how the Ethernet address. Now we are going to the MAC address, that is Ethernet address, and the IP address. Now we will work on the MAC address and the IP address. So Ethernet address is normally the 6 byte or 48 bit. 6 byte or 48 bit number. Normally written in the hexadecimal notation. It is the hexadecimal notation. You can see like this way we are writing any Ethernet number. Okay. So you can see here is a question that these are the define the type of following destination address. These are some addresses. Like this way we are writing. Now questions are coming like that, which one is unicast, which one is multicast, which one is broadcast, how to identify that. Okay. So always you have to check the first byte, from the first byte last bit. Last bit from the first byte. If you are taking that it is 0, then that is the unicast number. Means if it is a even number, then it is the unicast. Last number is 1, means it is a odd number. if it is a odd number, then that is a multicast address. This is the multicast address. So now here tell me, now then can you tell me that the first one is what type of address, second one is what type of address, and the third one is what type of address? Can you tell me? First one is what type of address, second one is what type of address, and the third one is what type of address? Yes, answers are coming. I can see the answer. Unicast, multicast. Which one? Give me answer like that. A is what? B is what? C is what? Give me answer like this way. Okay, answers are coming. Yes, just now I told that even that is unicast, odd that is multicast, all digit F that is called the broadcast. All digit F. So that's why you can see here in the 4A. Because if you are converting A, then this is the 1010. A means 10. That is a even number. That's why it is the unicast one. 7, that is a odd number. Last byte is 1. That's why it is a multicast address. And all FFFF, that is a broadcast address. Even also the broadcast, all the broadcast address, it is can be all bit 1. That's why it is also the multicast also. Although it is broadcast, it is multicast also because this is a odd number. It is multicast and broadcast both. You can say that. It is multicast and broadcast both. So every broadcast MAC address is multicast also. But all multicast is not broadcast. Clear? Yes. Clear to everyone? I hope so. Unicast, broadcast. So can you tell me what is this answer? What will be the answer for this one? Can you tell me what will be the answer for this one? Yes. All of you are wasting time here that ma'am so many things how to calculate. Here just divide it into 4 bit 4 bit. This is the first 4 bit, second 4 bit, again 4 bit 4 bit, again from here 4 bit 4 bit, then again from here 4 bit 4 bit, again from here 4 bit 4 bit, again from here 4 bit and 4 bit. Now ma'am I have to calculate everything like all the binary number. No need to calculate here, just check it. These all are 5A, 5A, 5A. So the first one no need to do. Focus on the second one. In the second one this is 0001 means that is 10001. This is also 1. And with that one only you can do the answer. This is not my answer, this is not my answer, this is not my answer. Definitely it will be my answer. Yes, definitely this will be my answer. Anyhow, other answer are not possible. So that is the correct answer here. It is the way how you can save your time. Next part is IPv4 header. From here also 10 marks question came. This is the another area from where 10 marks question already came previously. So what is IPv header and what is the IPv header format? How the IPv header format is working? Here IPv header format means their header minimum size is 20 and maximum is 60. 20 is always fixed header length. So in this header length you can see here, this is the version. Version is given in the 4-bit. Because using the 4-bit you can represent how many numbers? 0, 0, 0, 0 to 1, 1, 1, 1. That is, you can represent 0 to 15. These are the number you can represent, right? Total this number you can represent. So this many version can be possible. So IPv4 means how to represent? 1, 2, 4, 8. You can represent 0, 1, 0, 0. Means this is the IPv4. Another version is there, IPv6, that is 0, 1, 1, 0. That is IPv6. In this way version number, that is what type of network. Next one is the header length. Header length is also 4-bit. But the problem is that header length can be till 60. But using 4-bit you can do 0 to 15 only. Then how you can represent 60? That's why always the header length you have to multiply with 4. Because in the header length minimum, if it is 5, minimum will be 5, that is 0, 1, 0, 1. If you are taking 5, then 5 multiply 4, it will be 20. Maximum you can get 1, 1, 1, 1, then you are getting 15. 15 multiply 4, then you will get 60. So always remember header length, always I have to multiply with 4 to get the header original length. Types of service, there are different types of service will be mentioned with this 8-bit number. Next one is the total length. Total length will be given in the 16-bit, and these all the number are given in hexadecimal number. Always the hexadecimal number you have to convert in decimal number to get the original value. That is, always you have to multiply with 16. All the bit you have to multiply with 16, then you are getting the original number. This is the identification number, that is 16-bit. This is the, every packet have a identification number. This is the null bit, always that is 0. Don't fragment bit. It is telling that whatever packet I am sending, that packet is allowed to split or not. That packet is allowed to fragment or not. That is called the don't fragment bit. And this is the MF. This is MF, means more fragment. Whenever one of the fragment received by the receiver can understand with this bit. If it is 1, then it is not the end. It have more fragment till now. That is called the more fragment bit. And last one is the fragment offset, that is the 13-bit. This is the fragment offset. Next one is the time to leave, means total whatever time is allocated to the packet. After that time it have to leave the system. Unlimited time any packet cannot be allocated, because it will create the traffic congestion. So time to leave means total time will be given, and always it will be decremented, means whenever it start, if the time is given 20, always whenever one by one time is going down, it will be decremented. So with that one, remaining how much time is required, remaining how many router you have to, it can traverse. From here we can understand that. Protocol, there are different protocol, different numbers are there for different protocol. With that, this protocol will be mentioned. And this is the header checksum, through which the error detection, checksum is also one type of error detection code through which the checksum is working. Other than that, next row, it is the source IP address. This is the destination IP address. These are the mandatory part, that is total 20 byte. And after that 0 to 40, that is optional part, and then data will be added. Then you can add the data. This is the header format, how the IPv header format is working. I hope it is clear to you. Now tell me what will be the answer for this one. This is the 10 marks question. Upcoming total 5 question is from this IPv header format. Tell me what will be the answer. Tell me the answer. Do it and tell me the answer. Yes, here answer will be 20 byte. Why 20 byte? I will again explain, but tell me quickly. Next question. What will be the next answer? What is the size of the datagram? Yes, the size of the datagram is 84 here. Size of the datagram will be 84. Then the next one. What will be the next one? How many more router can the packet travel to? Here the answer will be 32. Yes. Then the next question is, what is the protocol of the payload being carried to the packet? What is the protocol here? Yes, the protocol is TCP protocol. This is the TCP protocol. And finally, what is the efficiency of the datagram? Finally, the efficiency of the datagram is this one. Now, how to solve it? As I told here, it is the hexadecimal number. One by one, you have to take the row. This is the first row. Each and every number is actually 4-bit because the hexadecimal number. 4 means it is actually 0, 1, 0, 0. That's why it is the 4. So 4 is 1, then 16 bit here. So here whenever you are taking the 4 bit, total 4 bit is, that is the 4, 5. Here it is 8 bit, that's why take the 2 number. Here it is 16 bit, means that's why you are taking the 4 number here. Out of that, now you can take the header length. Header length is 5 here. So what I told, 5 you have to multiply into 4, then you can get 20. So that's why your header length is coming 20 here. That's why your answer was 20 for the header length. That's why your answer is header size 20. After that, next part. Next row, if you are taking here, that is this 4-bit is your identification number. After that, this 0 is actually expanded to 4 zeros, because this is 1 bit, this is 1 bit, this is 1 bit. So 1 bit is here, 1 bit is here, 1 bit is here, and now this remaining 1 bit, it is here. This is the 13-bit number. So remaining these 3 zeros means it is actually 3 multiply 4, that is 12 zeros. It is actually, you can think like that, 0 after that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That is, these 13 zeros are here. That is done. Now after that, the next line, if you are coming to the next line, that is this 2006. So this 20 is the time to leave, 06 that is the protocol. After that, nothing is given to me. So from this 20 time to leave, I can calculate the router. How many more routers are there? 2 multiply 16 plus 0 multiply 16 to the power 0 to the power 1. That is 32. So that's why your answer is 32 here. When it is moving, that how many more router it can go, that is 32. In between, the datagram size, that was the requirement. So datagram size you can calculate from here, that is the total length. Total length was 5, 4 means 4 multiply 16 plus 5 multiply 16 to the power 0 to the power 1, that is 80 plus 4, that is 84. So from here you are getting the answer 84. 84 is including data plus header. If it is asking only data, then your answer will be 84 minus 20, that is 64. But it did not ask you only data, it is asking you the total datagram. That's why 84 is the answer. Next one is the protocol. Here the protocol number is 06. So from here you can see all the protocol number. 1 means ICMP, 2 means IGMP, 6 means TCP, 17 means UDP, 41 means ENCAP, 89 means that this one, 132 means this one. You can remember at least whatever the popular one, that is ICMP, IGMP, TCP, UDP. These are the most popular. So from here you can do it. Ma'am, how we know conversion to hexa? Read the question. Pooja, you are not reading question at all properly. It is given already that it is in hexadecimal. Question reading is most important part. Question reading is the most important part. If you are not reading question, then you are gone. Yes, only this 4 you can remember. At least this 4 you can remember. At least this 4. These are more popular. Okay. Then finally the last one is, what is the efficiency? Efficiency is payload divided by total length. So payload is actually 64. That is your actual data size. And divide by 84, that is your total length. So 64 by 84, you are getting here 76.19. That is the answer. Other than that, some question can be there. Are there any option in the packet? See that there is no option. Optional part is 0 here. Here you can see, if you are coming to the optional part, because the 0 to 40, it was nothing. Nothing was there. No option. Optional part is not there because. And here there is there any fragment? No fragment. Fragment is there, yes or no? You can see here, you can do the fragmentation. Fragmentation is 0. More fragment, is there more fragment? No, that is 0. So from this way only you have to split the number and you can get the answer. This question was the last exam question only, that is June 2023 question. They asked this question as a comprehension. So you have to be very much prepared about that. You have to apply little bit more mind. Comprehension question will be not direct question. Little bit mind you have to apply to solve the comprehension type question. So are you ready to do the next? If you are ready, then I will go, otherwise I will end. Is it okay? Can we go ahead? But my video is not okay. See that, now video is working. What the computer is doing with me, I don't know. When it's coming to hit, then that is working. Now see, it is working. Now after that, when it will stop working, I don't know. Computer is required hitting it now, not what? What is going on? See that, now video will work. For a long time it is not working. It was stuck. Now it is working. Chalo, as video is working now, we can. 6:30 p.m. class I will take. 6:30 p.m. class I will take. In the 6:30 p.m. we will do the practice. Okay, so there are two types of addressing, class full addressing and the classless addressing. Class full and the classless, that is classless is the inter-domain routing, classless routing, right? So class full addressing, you have to remember only that you are doing like this way. That is the 8-bit, 8. All the 8, total 32-bit data. Total 32-bit data is here. And this is very important. Class A, net ID 1 byte means 8-bit net ID, 24-bit host. Class B, 16-bit host, 16-bit net. Class C, 24-bit net and 8-bit host. And for class D, multicast, all are, and class E, all are reserved. Class E, all are reserved here, right? So class A, you can see here 0 to 127, class B 128 to 191, class C 192 to 223. The leading bit 0, here the leading bit 10, here the leading bit 110. These are the leading bits are here. Out of that, here are the some rule. These are the rules are there. All bit will be 0, that is your net ID. And all bit 1, that is your broadcast ID. 127 is always the loop back address. These are the some important points what you have to remember. I am zooming it, go through it and remember it. Okay. These are the all important points what you have to remember. Okay. Yes. Now here are some special thing, that is the local addresses. 169 to 169, this is the local address. 127 loopback address. 020, this is the DHCP address. 255 that is the broadcast address. And this chart is very important chart for your networking, where everything is together. Total how many network possible, total number of addresses possible, and starting address, ending address. Very important. Very important. Yes. Now tell me, do quickly the question, and here also subnetting question we will cover. Then I have to end, because subnetting there is the comprehension type question here. So as I thought that yes, all the comprehension type question from which area question came and what are the confirm area. that I will cover today. So do this question and I will go to the comprehension question also. Do it. Yes, that is doing the both network and host. Then tell me what will be the answer for this one. Tell me what will be the answer for this one. Yes, so here you are getting, this is your answer. Here also you can apply that same method. This is 1 1, this is also 1 1, same number, so same number is here only. Now tell me what will be the answer for this one. What will be the answer for this one? Yes, here the answer is just now booted, that is 0.0.0.0. Now tell me what will be the answer for this one. All are subnetting related question. Yes, here the loopback address is the class B, that is wrong because loopback is 127, that is class A, this is not the class B. And loopback address, this is correct one because it is going to itself, that is correct one. So answer will be this one. Now tell me what will be the answer for this. What percentage of IPv4 IP address space do all the class C addresses consume? Yes, here your answer will be 12.5% because why? Because total is 0 to 255. Class A is 0 to 127, that is total 128. So total 256 out of 128, that is 50%. In that way you can calculate the remaining also. Same way with the range, that is 129 to remaining. How many total addresses are there out of 256? You can calculate the remaining one and you can get the answer like this way. This is the total 128, 64 out of 256, 32 out of 256, 16 out of 256, and this is also 16 out of 256. So in that way you are getting this answer. Now it is your next question. Tell me what will be the answer for this one, and that is the comprehension type question of 2022. From here 5 question, 5 into 2, 10 marks question came. You can see from networking how much repeating area is there. So many areas they are asking the comprehension type question. Yes, here your answer will be 64 because it is 130.56.0.0. Total 16 is already allocated here for the net. 1024 subnet means 2 to the power 10. So 2 to the power 10 means already 10 bit is allocated for the subnet part. So 10 bit will be for the subnet part. Then remaining 6 bit will be for the host part. So using the 6 bit, how many addresses you can create? 2 to the power 6, that is 64 addresses you can create. This is the way always you have to do the subnetting. How many subnet is required, convert it into 2 to the power, then the host, remaining part will be the host, and how many host, that many host will be possible. Do the next one. Find the subnet prefix. Yes, definitely it is sure that 130.56 this part is not changing. That's why this is my subnet prefix. Now after that, what will be the answer for this one? Find the first and the last address of the first subnet. Find the first and the last address of the first subnet. Yes, here your answer will be 130.56.0.0 and 0.63. How it is, where it is, I am telling, but do this one, then I am coming. Find the first and last address of the last subnet. Yes, here your answer will be this one. How to do that? Total you are able to create 1024 subnet. How it is? 130.56, this part you cannot do. But remaining 10 bit, that is first one will be 1, 2, 3, 4, 5, 6, 7, 8, then 9, 10. This is my first subnet. After that, here the first host and last host. How it is? From here the first host will be 130.56.12345678910, that is the fixed. After that remaining 6 bit all are 0. 1, 2, 3, 4, 5, 6. That is the first host of the first subnet. This is your first subnet, and then this is your all zeros. And after that, here whenever you are taking this one, that is 130.56.12345678910, then after that all 1. That is 1, 2, 3, 4, 5, 6. That is your last host. So that's why here your answer is coming 63. This is 0 to 63. Because this is your 0 and this is your 63. And for the last one, what will be the last one? That is 130.56.1234567 all one, then 9 10. That is the last subnet. After the last subnet, we have to do the first host and last host as it is, same way. So for the first host, you can take here all zeros. That is 1, 2, 3, 4, 5, 6. That is all zeros. And last one will be like 130.56.1234567 9 10. Then all one for the last host. 1, 2, 3, 4, 5, 6. That is actually this number is 192 and this number will be 255. This is the already 255. So that's why you are getting this number. This is the way they are asking question. Now you can see what will be the subnet mask. What will be the subnet mask? Tell me what will be the answer for subnet mask? You all are doing mistake because here subnet mask means how to do the subnet mask. All net bit and subnet bit 1 and host bit 0. That is called subnet mask. Okay. So that's why here all the options are actually wrong. All net bit and host bit 0 means 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. This is your 16 bit net bit. Then after that 10 bit is the subnet. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is your subnet bit. That is also 1. Then after that host will be 0. 1, 2, 3, 4, 5, 6. That is your host is 0. This is your number and this number will be 255, 255, 255.192. All the answers are wrong. All these answers are wrong. All these answers are wrong. Any of the answers are not correct. Any of the answers are not correct. All these answers are wrong. Answer will be 255 and it is a drop question. Okay. All this answer will be wrong here. Okay. Be careful about the subnetting. So just do one thing. Do a mind mapping always. That whenever you are doing net ID, it is asking net ID. Then remember that all net bit as it is, keep it as it is, and host bit 0. That is your net ID. If it is asking you broadcast ID, then all net bit as it is and host bit 1. That is your broadcast ID. If it is asking you mask, then all net bit and if the subnet, then subnet also 1 and host bit 0. That is your mask. These are the three things. Remember how to do it. These are the three things always important, and they are asking question. And whenever you are doing the range you can do from all 0 to all 1, but always the first host is your net ID and the last host is your broadcast ID. They are allocated, always they are allocated. Okay, and another thing is that ki limited broadcast and the direct broadcast. So limited broadcast is always 255.255.255.255. That is always the limited broadcast, because within a organization you are sending to all. That is limited broadcast. Direct broadcast means from outside the world you are sending to one organization. That is the direct broadcast, and this direct broadcast you have to calculate in this way. That is all net bit as it is and host bit 1. That is the way you have to do the direct broadcast. That is we have calculated here. This is your this is actually your mask. If you are asking about the direct broadcast for this one without subnetting, then the direct broadcast will be 130.56.255.255. That will be the direct broadcast for this net, not the subnetting, for only for this one, not the subnetting. Without subnetting, whenever you are doing, then that is your direct broadcast. Okay, so here is another last one that is important: circuit switching and packet switching. Theoretical questions are coming from here. In circuit switching had the three phases: connection establishment, direct data transfer, connection release. Packet switching, in the packet switching directly data transfer takes place. Circuit switching, each unit known as entire path address. Packet switching, just known the final destination. Circuit switching, data process at the source system. Packet switching, data process at all the intermediate node. The delay between the data unit and the circuit switching is uniform here, and the delay between the unit and the packet switching is not uniform. Resource reservation of the circuit switching, data retransmission here, and no resource of this here. Circuit switching is more reliable, but packet switching is less reliable. And there are some more difference that are you can go through it between circuit switching and packet switching. Questions are coming from this area. You can see this question on circuit switching and packet switching. You can see this question. Tell me what will be the answer for this one. Okay, so answer will be this one, because here it is given that which one is false. Packet switching resulting the less variation in the delay than the circuit switching. Less variation is here in the delay than the circuit switching. That is wrong, because here it was, you can see that circuit switching is more. So So that is the wrong answer. Okay, because here the circuit switching has the less variation than the packet switching. It is correct. So that's why opposite one will be wrong. Here is the difference between some routing protocol. There are different types of routing: intra-domain, inter-domain. Intra means inside the domain, distance vector and link state. Example RIP, and here the example OSPF. So inter-domain means between two domains. That is, the routing algorithm works both within and the between the domain. Intra-domain means it is within the domain only, inside the domain only. So here you can see the difference between intra-domain and the inter-domain. Routing algorithm works within the domain, that I told. It's need about the router within the domain. It is between the domain. Protocol intra-domain routing known the interior gateway protocol. It's known the exterior gateway protocol also. And here within the anonymous network, here routing takes place between the autonomous network. Inter-domain routing ignore the internet outside the autonomous system. Intra-domain is this one. And the popular one, that is RIP, Routing Information Protocol, OSPF, Open Shortest Path Protocol. Here the popular one is BGP, that is Border Gateway Protocol, and connected to protocol, that is AS, Autonomous System. These are the difference between inter and intra. You can see the intra-domain means inside the domain. Inter-domain, domain 1, domain 2, domain N, all are connected. That is the inter-domain. Here the difference between static and dynamic routing. Static and dynamic routing means the static routing routers are user defined. Dynamic routing, router update according to the topology, whatever topology you are using. Static routing does not the complex routing algorithm, and dynamic routing is very complex because dynamically it is updated. Okay. Static routing provide the high to more security. Dynamic routing provide less security. Static routing is manual. Dynamic routing is automated. Static routing implemented in small network. Dynamic routing implemented in large network. Static routing additional to the not required here, but dynamic routing additional sources are required here. Static routing failure in the link interrupt. If the link disturbed, then it can failure, but dynamic routing failure but link does not interrupt the rerouting. Here bandwidth required for the static routing, more bandwidth required for the dynamic routing. Other than that, this is non-adaptive routing, and another name is dynamic routing is adaptive routing. From here theoretical question, numerical questions are also coming. This is the distance vector routing, this is the link state routing. Here is the difference between distance vector and the link state. What is the difference? Here you can make with the algorithm. The Bell-Manford algorithm yesterday we discuss, and disaster algorithm, that time I told it is related to your routing. Remember that exactly link state routing is working as per disaster, and distance vector routing is working as per Bell-Manford. So the bandwidth required in less due to the local sharing, small packet and low flooding. Here the bandwidth more because flooding and sending large link to the packet. It is based on local knowledge since it updated the table, and it is based on the global knowledge. Here the Bell-Manford is required. Here traffic is less, traffic will be more. Convert slowly. Good news spread fast, but bad news spread slowly. It is the problem. And here converges faster because they are linked together. Count infinity problem is there, but here no count infinity problem. There is no count infinity problem. Persistent looping problem is forever, but no persistent looping problem is here. Practical implementation is RIP and IGRP. Here practical implementation is OSPF and ISIS. These are the practical implementation. Okay. So here these are the some example of routing. You can see how they are working. And this is with the table, how the table is updating exactly just like Bellman-Ford algorithm. And this is your link state just like the disaster algorithm. How you can relate with the disaster algorithm, just like disaster algorithm it is working. Okay. So here you can see a question, and this is the last question. I have to end the class because 6:30 students are waiting. I have to go live there also at 6:30. So do this one. 6:30 there is paid learner. How many paid learners are here? How many paid learners are there? I think those who are doing regular classes all are here, right? If you agree, then I can complete the remaining part here only. Remaining means only the network security is remaining. Some question. All are here. Only the network security is remaining, because I know whenever I am asking question you are not able to do. Whenever I am asking question, then you are not able to do. That's why I am taking this mind mapping. All are here. So what you want? Read. I have to read. What you want? If you are allowing, then I can complete the remaining part here and we can do again morning. Alright, okay. So consider the computer network using the distance vector algorithm and its network layer. The objective to find the shortest cost path from the router R to the router P and Q. Assume that R not initially known the shortest router to the P and Q. Assume that the three neighbors are there. So it is a big story. From that big story you have to find out the small part. First part is there, this one, that find the shortest path between the router R, P, Q. So here is the R, here is P, here is Q. Okay. Assume R does not initially know that shortest distance. Neighbor are X, Y, Z. So X, Y and Z are the neighbor here. After that, during one iteration, R measure the distance of 2, 3 and 5. So here this is 3, 2, 5. Router R getting routing vector, its neighbor indicate the distance 7, 6, 5. That is you can get from here. Key this one is 7, and this one is 6, and this one is 5. That is the 765. Okay. And after that, here you can see that routing vector from Q XYZ is getting 648. So you can get this one, that is, sorry, here this 6 was this one, this is that 6, and from here you are getting this 6, 4 and 8. Like this way they are connected. Now you have to find out the minimum distance between them. That is the thing. Question is asking you actually the distance between RP. This is the distance actually they are asking. So how to find out the distance? That is here important. How to find out the distance? You can see here from the R to P. If I am finding the distance between R to P, there are different way I can find out. That is 3 plus 7, 2 plus 6, 5 plus 5. Which one is less? So out of them 8 is the less. That is this one. I can go through Y, R to Y, then Y to P. That is 8. This is the latest smallest distance. If I am trying to find out the distance from the R to Q, what is the shortest distance? So the R to Q, the shortest distance I can get from different way, but the minimum one is through the X, that is 3 plus 4, 7. That is this 7, 3 plus 4. So R to Q, I am getting R, then X, then Q, that is 7, and R to P, I am getting R, then Y, then P, that is 8. In this way I can get the answer. So that's why my answer will be definitely the distance between R to P is 10. No. The distance between R to Q is 7. Yes. The next hop of the router packet R to P is Y. Yes, that is correct. So B and C is the correct answer. Yes, clear? Is that clear? Okay. Okay. Yes. Only the last part is cryptography. Maybe hardly 10 to 15 minutes will be required to complete the cryptography part, so that whatever I promise, that complete networking, all the important topics, mind mapping will be done. Because we came to the last one, that is the cryptography. Okay. That is the last one we will do. Yes. Yes, because the concept I will complete. After that, definitely if you are interested, I will take the class. No problem. I will take the class. But taking class, as per my experience, without concept, so many learners are coming, but you are not clearing your concept and you are not able to do the question. So it is the cryptography. Cryptography means actually the encryption and decryption, so that anyone else cannot take your data, cannot steal your data, right? They are not able to affect your data. That is the main problem. So in the cryptography, these are the very important terminologies: confidentiality, integrity, non-reputation and authentication. Confidentiality means information can access by the person from whom it's intended and no other person except him can access it. Integrity, information cannot be modified in storage or transition between the sender intended receiver without additional information, that is integrity. Non-reputation means the creator or sender information cannot deny. Authentication means identities of the sender and receiver are confirmed here. That is the authentication. So here there are symmetric key, asymmetric key and hash function. These are the different cryptography. Symmetric key means when sender and receiver are using the common key, that is called the symmetric key. Asymmetric means the encryption and decryption information. There are two types of key. Public key used the encryption and private key used for the decryption. Public key and private key are different here, and even also the public key known as everyone intended to the receiver, but private key will be always private. Okay, ठीक है, private key is always private here. Yes. Now next one is that the hash value. A hash value is the hash function, just like the hash function that is working. Hash function means it is not the hashing. It is not the hashing. It will generate a secret code and it is one way. If you are giving the input, after that the hash value is generated means it cannot be revert back. It is not able to revert back. And always this type of encryption is used for the password purpose. Okay, these are the different types of encryption technique. In cryptography, symmetric and asymmetric, these are the example: blowfish, two-fish, here 3DS, AEDS, IDEA. Here it is DH, SSL, RSA, very popular algorithm. Questions are coming from here, and the SSH. This is classical, modern, substitution, transposition, mono, these are symmetric and asymmetric, block cipher, stream cipher, RSA, DSA, all these are your important part. Okay, here I can come to the directly transposition cipher. How the transposition cipher is working, that is very important. Question already came from here. You can see that this is meet me after the party. Just we are writing like column wise, one by one you are writing meet me after party, because here 1 2 3 4 5 6, this is my key, use of key, that is we are writing in jumble way, 4 2 1 6 3 5, because key is used here. So the fourth column together I am writing here, second column together I am writing here, first column together I am writing here, sixth column together I am writing here, third column together I am writing here, and the fifth column together I am writing here. All these column whenever we wrote here, then you are getting the cipher text. This is the way you will get the cipher text. Okay, so from here okay, Raminuddin, thank you. So tell me, what will be the answer for this one? Tell me what will be the answer for this one? Tell me what will be the answer. Okay, answers are coming. So what will be the answer? Answer will be the fourth one. Fourth one is the correct answer. Why the fourth one is the correct answer? Because just write it in this way. 1, 2, 3, 4. Hello. HELLOAMYDEARZ. That is the way you have to write. Now this is 2431. So write it in that way, 2413. So second one EMA. Fourth one LDZ. First one, this is the first one, HOE. Third one LYR. Yes. So ultimately you are getting ELHL, that is ELHL. MDOY, that is MDOY. AZER, that is your answer. Clear? How to do? The last one and very important one is the RSA, and with the RSA I will end the class. Tell me what will be the answer for this one, RSA algorithm. How the RSA algorithm is working? In this way they ask the question. What will be the answer here? Yes, the sequence of RSA algorithm is this one. That is, first of all we are taking the two key, that is P and Q. That is this one. After that N equals to P multiply Q. That is this one. After that you have to compute a number. Compute the lambda n. Sometimes we are telling phi n. That is the next one. Then we have to choose a number between 1 e between lambda n. Then finally we are doing the phi n also. Phi n equals to p minus 1 multiply into q minus 1. Then actually e multiply d equals to 1 mod phi n. Like this way it is working. Although they provide half of that. So your sequence will be this one. This is the correct sequence. Now do the answer of the RSA algorithm. That is the RSA algorithm given to you, and you have to tell me what will be the answer for this one. Then I will leave the class. I will end the class. You will get relaxed. What will be the answer? Tell me. Answer quickly. Okay, answers are coming. Option 3 is the correct answer. How to do it? Here you can solve in this way. Here I already solved for you. P equals to P and Q equals to this one, 3 multiply, as I am doing it with you so that you can see that. Here P value equals to 3, Q value equals to 11, D value is 7 and M value is 19. So I have to do N equals to P multiply Q and phi N equals to P minus 1 multiply Q minus 1, right? So here it is 2 multiply 10 means 20. So then we have to do E multiply D equals to 1 mod phi N. Now where is the confusion? Students are getting confused here. How to get the value? Here E value not given but D value is given to me. E multiply D equals to 1 mod phi N. So E multiply 7 equals to 1 mod phi N is 20. I am getting here 20. So out of that, now how to put this number? You have to put this number so that it can be divisible by 7. So 20 multiply into 1 plus 1. 1 mod 20 means x is the number. If you are dividing by 20, then 1 is the remainder. So what is x? How you can find out? 2 multiply 1 plus 1. 20 multiply 1 plus 2. 20 multiply 2 plus 1. 20 multiply 3 plus 1. 20 multiply 4 plus 1. Any number will satisfy this thing. But out of that, the first one, what is divisible by 7? That is 21 definitely, because 20 multiply 1 plus 1 is 21. So in this place I can put 21. So E will be 21 by 7, that is 3. So you are getting it 3. Now after that, ciphertext equals to M to the power E mod N. That is the message, whatever message is there, 19 to the power 3 mod 33. So 19 to the power 3 mod 33 if you are doing, then here you are dividing it and you are getting this answer. That 6859, then 33 if you are dividing, you are getting the answer modulo means 28. Okay, so you are getting the answer 28. So that's why your answer will be here 3 and 28. That is the answer. And actually the 28 no need to calculate. Whenever you got the answer 3, with that one only you can do the answer. Because here only with 3 I can get the answer. No need to waste your time for division. Without wasting time, you can do it. Right? Yes. Yes. Acha, do this one. This is the matching also very important. DES, AES, 3DES, RSA. All these matchings are coming. That is also very important. All these matching are important for you. What is the key size? What is the key size of each and every cryptography? These are different cryptography algorithm and you have to remember this all the algorithm. So here you can see DES key size is 56, AES key size is 256, 3DES key size is 168, RSA 1024. Must remember 3 to 4 times they ask question from this key size. Must remember it. So here you can see the difference between the AES and DES. I cannot zoom here, but I think I can do one thing for you. I hope now this one will be visible to you. So here you can see the difference. AES stands for Advanced Encryption Standard. DES is Data Encryption Standard. Key length 128, 192, 256. Here the key length is 56 in DES. Here the number of round 10, 128, 12, 192, 14, 256. DS involves 16 round identical operation. Structure based on substitution permutation network. Okay. Substitution permutation network. And here the structure is this network. Design is AES open, here DES closed. Selection accepted here. Public comment, selection is secret here. AES, DES is this one, stand for this one, 3 DES. Okay. After that, here is the difference. You can see already I discussed the difference with you. So this is the end. Chalo. Acha, another one came. I forgot that CRC. I forgot that CRC. I add all the important topic for your exam. Tell me what will be the answer. That is one type of error detection. CRC. That is also most important. Last one. I am telling you from long time. Last one. I am very much crazy, right? Tamil, 1 mod 40 means you don't know. 1 mod 40 means you have to do that x is the number, 40 you are dividing, you are getting 1. So 40 multiply 1 plus 1, that is 41. 40 multiply 2 plus 1, that is what it will be, 81. Then 40 multiply 3 plus 1, that will be 121. That is the simple thing. Whatever you are doing, 1 mod n means your n is the number, x 1 is the here. So you have to do n multiply 1 plus 1, n multiply 2 plus 1, n multiply 3 plus 1. That is the simple thing. Tamil. That is the simple thing. Okay. Yes. So here the CRC, what will be the answer? Here the CRC answer will be this one. Although it is very simple, they give you everything, even also they give the divisor, they give the remainder also. But how we are calculating this one, 1010, if the remainder is not given to you, then you have to do like this way. There are 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And how many bits are there in the divisor? You have to take minus 1, 0. Means there are 4 bits, take 3 zeros. Then do the XOR operation. Do division like that way. 1, 0, 1, 0. Then do the XOR operation. 1, 1 is, here 1, 0 is 1. 1, 1 is 0. 1, 0. 0 will be discarded, then 1 will come down, then again take 1 here, then again 1, 0, 1, 0. So here 1, 0 is 1, 0, 0, it is 0, all the discarded. Now again you have to take this 1 and then you have to take this 0 also. Then you can take here also 1 means here you have to take this 0 also. Then you can take here again 1, 0, 1, 0. So 1, 0, 1, 0 means this will be 0, this is 1, this is 1 and that is 0. This 0 is discarded. So finally you are getting here 1, 1, 0. Okay, finally you are getting here 1, 1, 0. That is the final answer you are getting. In this way you will get the final answer. 0, 1 is 1, 0, 0, 0. So you get the 1, then 0 0, and finally you cannot continue more. And now you have to, little bit confusion. Where is the confusion? Here I took any one extra, I think. 1 2 3 4 5 6, then 0 0 0, 1 0 1 0, 1, then 1 came, then 1, then 0, then 0 1. Yes, 1 1 0 is the remainder. After that you cannot, because 3-bit remainder, then you cannot continue. So that's why 1 1 0 will be the answer, and in this way you are getting remainder. So just remainder you have to add with the value, whatever value is given, with the value add the remainder. That is here, this is the remainder. That will be your ultimate data what you have to send. Okay, chalo, finally my slide is over. And finally, ma'am, how you got the answer in division, not remainder? You are not getting the answer in, it is the remainder. This division is not required. This is the XOR operation. We are doing XOR operation here. What we are doing here, I am writing again. 1 2 3. What is the divisor? This is 1 1 0. After the class I don't want to see any problem. 1 1 0, and here it is 1 2 3 4 5 6, right? And this is 1 0 1 0. Sorry, this was 1 0 1 0. So after that I will add more 3 0. 1 2 3. Then here it is 1. Then what it will be? 1 0 1 0, right? So I have to do XOR operation. 0 1 is 1, 1 0 is 1, 0 0 is 0, 1 1 is 0. That is the XOR operation. That is the XOR operation, right? This is 1, this is 0, this is 1, this will be 0, it will be discarded. After that take this 1. Then here it is 1, means again 1 0 1 0. Then this is 1, this is 0, this is 0, this is 0. So now take this 1, take this 0, take this 0. Now after that again 1 0 1 0. Now it is 0 1, and this is 1, and this is 0. Now this 0 is discarded, you are getting the remainder. This is the remainder actually. And after that, actually correctly if you are doing, then you should continue this process once more. That is, this 0 should come again, you should take this number, that is 1 0 1 0. Then this will be 0, then this will be 1, then it will be 0. Actually this should do like this way. This will be 1. Then you are getting final result, because till whenever it's end, then only you can stop. So here you can stop. Whenever here you are stopping, then you are getting this answer will be discarded. You cannot continue more, and you are getting this answer. But although it is given in the question, it is already given, no need to do. Just you can add the remainder with this number, that is 1 2 3 4 5 6, and remainder is 1 1 0. Put it and get the answer. Okay. Yes. Ma'am, can you answer option without doing by looking? Option means without looking option only I am doing the answer. That is only I am doing. Here is the answer. You can see the answer. This is the answer. I am not looking on the option. I am doing it, and without checking only I am doing in front of you, and in this way only it is solved. And sometimes it can be in the x, like that. Ki this is your factor x, x to the power 0, x to the power 1, x to the power 2, x to the power 3. In that way you have to complete. Okay. ठीक है. without doing we can do. Definitely I am doing that because so that you can understand how to do CRC. It is given, it is already given, no need to do this process for this question. But those who don't know how to do CRC, for them I did it. It is already given, no need to do. Without doing we can. But I did it so that others can understand how to do CRC. Okay? So that others can understand it. That is my target. Okay? Chalo everyone, ultimately we complete all the networking important topics. Everything is here. And paid learners, I am going to upload this PDF for you. You can go through this PDF. And everyone, you can practice the question. Today I have uploaded the PYQs, all the questions already we did. Morning also we did practice. And now I am going to upload this PDF. Go through it, revise it, practice it. All these important topic we did here. And like, share, subscribe, comment. After the class, must comment into the comment section. I am putting my 100% effort for you. I will request everyone, try to put your 100% also. Try to put your 100% also so that you can get a good score. Okay. Bye everyone. Bye. See you again tomorrow.